Elements of a particular group show similarity in, or rather, they have the same outer electronic configuration. They, however, vary with respect to the principal quantum number, and so they show the same valency and show similarity in the oxidation states. And that is what we learned in the previous video. However, the elements in the second period of the periodic table show a difference with compared to the other elements in their respective groups. So this means lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine show a difference in their properties compared to, difference in properties with comparison to their respective groups. For example, uh, the elements of the first group have a tendency to form ionic compounds or form ionic bonds. However, lithium, on the other hand, forms covalent bonds. Beryllium, similarly, forms only I'm so sorry, it also forms only covalent bonds, which whereas the other members of the group tend to form ionic compounds. So they elements in the second group period of the periodic table show similarity in the element which is diagonal to them. So, for example, lithium shows similarity in properties with magnesium, beryllium with aluminium, boron with silicon, carbon, and phosphorus. And this, in turn, is because of the three reasons. First is the size. So, the size of these elements, that is in the second period, is relatively less compared to the elements of its respective group. As we know, the size of the electron increases as we go down the group. So the elements in the second period have the smallest size compared to the other elements of their groups. Secondly, highly electronegative. So as we know, electronegativity decreases as we go down the group. And so these elements have a higher, they have a higher electronegativity compared to the other elements of the same group. Now, absence of d orbital. The absence of d orbital is because obviously in the principal quantum number 2 shell, we know that it does not have a d orbital. It only has 2s and 2p. And so because of this, this in turn leads to the anomalous behavior. Now, if you remember, when we learned about electron gain enthalpy, the electron gain enthalpy for oxygen, fluorine, basically all the elements, the second period was comparatively less negative than that of the third period. And this is again due to anomalous behavior. Not only that, the size also matters with respect to the anomalous behavior. Smaller size leads to that in the first place. If you notice over here, you have the metallic radius and the ionic radius. So lithium is showing more similarity in the radius as that of with magnesium. And not only that, if you notice here, lithium Li plus has 76 as its ionic radius, and magnesium is just 72. So the difference between the two is quite close. However, they form different ions, but the ionic radii are almost the same. So we will be learning about the diagonal relationship and anomalous behavior of the elements when we learn and discuss about the various groups in detail. And that I think will be in one of the next, maybe after a few chapters, and that will give you a clearer idea. But you just need to know the reason that this exists is because of the small size of the elements of the second period, the absence of d orbital, and high electronegativity compared to the elements of their respective groups. With that, we complete the anomalous behavior. Next video, I think we'll be discussing about the chemical reactivities. Do check it out.